Hello, our next topic is the functional group. Functional group is defined as atom or group of atom, single, double and triple bond, all which impart characteristics properties to organic compound. Those are called as functional group. For example, in case of single bond, as all parent hydrocarbon containing a single bond, so single bond itself is a functional group. This is, for example, ethane. In case of ethane, all bonds are single, so it has a different properties from all others. In case of double bond, the first member is ethene. First member is ethene, but due to the presence of this double bond, this compound has totally different properties from this compound. We know that all saturated hydrocarbon containing single bond, they will show substitution reactions, while the compound containing double bond, they will show addition reactions. The compound containing single bond will be less reactive. The compound containing double bond will be more reactive. In this manner, due to the presence of this double bond in an organic compound, as the properties are totally changed, that's why this double bond is considered as a functional group which has created a unique or different types of the chemical properties in organic molecule. Next, third one is the functional group for alcohols, and it is represented as OH. OH is the functional group representation of alcohols. The general formula for alcohols are CN, H2N plus 1 and OH. Now this is the OH which is using here as a functional group. If we put the different values of N, we will get definitely different types of alcohol. The first will comes methanol. Depending upon the number of carbon atom present in the alcohol, we will write the name according to the alkanes. For example, this is containing only one carbon atom. We will write down methane first. But due to the presence of this OH group, this E will be removed, will be replaced by OL. Automatically this will become methanol. Now this alcohol is containing two carbon atoms. First of all, we will write down its name. Its name is ethane. Two carbon atom containing hydrocarbon is called as ethane. But due to the presence of this group, this will be changed OL. This alcohol will become ethanol. Now all these, according to this general formula, alcohols produced will be monohydroxy alcohols, but the alcohols might be of di, tri or tetrahydroxy also. For example, we can name this CH2 if both the carbon atom is containing OH group. Then what we will do? We will number first both the carbon atom. This is carbon 1, this is carbon 2. Anyone can be assigned number 1 or number 2. But when we will assign the number, then we will write down quite easily 1, 2, then dihydroxy hydroxyethane can be named as, but this can also be named as 1,2-ethane. Now removing E, we can write diol, ethane diol. This is also the name of this alcohol. Similarly, there might be so many other alcohols which contain more than one OH group. So the OH group can also be mentioned as a branch, as a substituent, or this OH group can be used to mention the name according to alcohol, removing E of hydrocarbon by ol. For example, this is another compound. If we want to name this, what will be the name? The name will be 1,2,3 propane triol. Propane 1,2,3 or 1,2,3. Total are 3 propane and all carbon containing OH group. That's why 3, due to 3 OH group, name will become 1,2,3 propane triol. It means that if we have to mention the OH group at different position, first of all we will number the carbon atom and then mention the position of OH group present on different carbon atom. There are some common names. For example, this alcohol is also named as glycerol from the biological knowledge, because the glycerol is utilized there. Now OH group is basically the group of alcohols, and this is also a functional group. Now functional group, while naming the organic compound, functional groups are preferred always. Functional groups are preferred. For example, if we have this compound CH3, CH2, CH and then CH3, and if the functional group is present here, if the functional group present is for example here, it means that this is, if we start numbering to name this, we will number the carbon atom containing functional group as a number 1, or we have to allot a smallest number to the carbon atom which is containing any functional group. It means that this will be named 1, this is 2, this is 3, this is 4. It means that we will write according to the rules total number of carbon atom depending. This will be called as a butane because 4 carbon atom are there, but the OH group is present on first carbon atom. That's why we will call it butane 1-ol. This is the name of this. And if this OH group is present at this carbon atom, OH group, then this will be called as a butane 2-ol. Butane 2-ol. In this manner, the functional group, while numbering the carbon atom, is taken into consideration. The carbon containing functional group will be allotted the lowest possible number, and according to that we will name the organic compound. Similarly, the importance of a functional group, if we say, for example, this is our compound CH2 double bond, CH, CH2 and CH3. Now, this compound is containing 4 carbon atoms. As both of these carbon atoms is containing double bond. That's why the numbering will start from this side, not from this side, because the functional group will be given preference. This will be number 1 carbon, second carbon, third carbon and fourth carbon. Now what will be the name? The double bond is present between these two carbon atoms. But remember, the double bond will be considered of carbon which is having lesser number, smaller number. So name of this compound will become 1-butene. 1-butene. This 1 is indicating that the double bond present between first and second carbon atom, and the double bond is considered of carbon number 1. But if the molecule is just like this, CH3, CH, double bond, CH and then CH3, we are noting that from either side we number the double bond is at the same distance. That's why no matter from where we start numbering, it doesn't matter. If we consider this is number 1, this is second, this is third and this is fourth. In this manner, the double bond is present between second and third carbon atom, but the double bond will be associated with the lesser number of carbon atom, which is 2. So name will become 2-butene. 2-butene. In this manner, the functional group is always taken into consideration whenever we have to name the organic compound. The next functional group is halogens. Halogens, which is represented as a capital X. Capital X mean either fluorine, chlorine, bromine or iodine, any one of them. The general formula for the functional group halogens, these compounds will be called as halogenoalkanes, and general formula will become CnH2n plus 1 and then capital X. These are called as halogenoalkanes. If we take X as a fluorine or chlorine or bromine, we can get by putting different number of value of N into variety type of the alkyl halides. For example, if I put value N is equal to 1, then CH3Cl will become. If we are taking X as a chlorine, then this will be called as chloromethane or methyl chloride. Chloromethane is the most common systematic name used. Chloromethane. Similarly, if we want to write down this just like this, Cl and then Cl. Now the numbering becomes important. We will write the name of this. Definitely this carbon will be given number 1 because this contains 2 functional group alkane and this carbon is containing no functional group. That's why this carbon will be given number 1 and this will be given number 2. What will be the name comes for this? We will write down 1,1,1-dichloro and 2 carbon atoms are present. That's why this will become dichloroethane. 1,1-dichloroethane. On the basis of the carbon bonded with other carbon atom, these halogenoalkanes are of 3 types. These are of 3 types. One is called as a primary halogenoalkane, second is called as a secondary, and third is called as a tertiary halogenoalkanes. Now, in case of primary halogenoalkanes, the carbon atom containing halogen group is further attached with only one carbon atom, or the carbon having halogen group is containing either 2 or 3 hydrogen atoms. For example, if I write down here CH3 instead of HCl, chloroethane, this is a primary halogenoalkanes. Now CH3, CH2, Cl, this is also a primary halogenoalkanes because this carbon atom is containing halogen group and this is attached with only one carbon atom, and 2 hydrogen atom is still present. These 2 hydrogen atoms are still present with that carbon with containing halogen group as a functional group. This is also called as a primary halogen. Now look at this. This Cl. Now the carbon atom containing halogen group is having still 2 hydrogen atoms in this compound. So this also will be called as a primary halogenoalkane. Primary halogenoalkane. Now name of this hydrocarbon, the name of this organic compound will be just like this. If I say this is my number 1, this is second, and this is my third carbon atom, how I will mention the name? The name will be 2,2,2-dimethyl because the same second number carbon atom containing 2-methyl group as a substituent. That's why this is mentioned as 2,2-dimethyl. Then 1-chloro, 1-chloro. How many carbon atoms are there? 3. So name will become propane. 2,2-dimethyl, 1-chloropropane, and this is also the formula for the primary halogenoalkanes. Now, in case of secondary halogenoalkanes, the carbon atom containing halogen group is directly attached with 2 carbon atom minimum, or which contain only 1 hydrogen atom with it. This is called as a secondary halogenoalkane. Secondary halogenoalkane. Now name of this compound will be, if I say this is my number 1 carbon atom, this is second, and this is third, automatically this will be called as a 2-bromopropane, because hydrogen is not a functional group, neither it is any type of particular group which is required to be mentioned. The name of this will become 2-bromopropane. This is secondary halogenoalkanes in which the carbon containing halogen group is further directly attached with the 2 carbon atoms. And in case of tertiary halogenoalkanes, the carbon containing halogen functional group is directly attached with 3 carbon atom, or the carbon containing halogen group have no hydrogen atom with it. This is called as a tertiary halogenoalkane. Now, the name of this tertiary halogenoalkane is, how we will name this? We will select the longest chain. That might be my longest chain. I will give the name and numbering 1, 2, and 3, and depending upon the numbering, I will mention that 2-methyl, and 2-bromo. How many total carbon atoms present in the longest continuous carbon atom chain? That will be called as a propane. So this will be the name of this organic compound: 2-methyl, 2-bromo, propane, 2-methyl-2-bromopropane. In this manner, this is the tertiary halogenoalkane, this is the secondary halogenoalkane, and that was the primary halogenoalkanes. I have explained all the rules and all the basic principle regarding naming organic compound with respect to the different functional group. I hope you have understood. Please comments, like, share and subscribe my YouTube channel for the further upcoming lectures. I thank you all.